Configuration drift is the primary failure point in manual Kubernetes operations. To eliminate it, we establish Git as the single source of truth. This means all desired state manifests reside exclusively in a Git repository. ArgoCD acts as the continuous delivery agent, constantly comparing the live cluster state against the committed repository state. Start by structuring your repository. Separate application manifests, typically in a dedicated application directory, from infrastructure configuration files. This separation ensures clear ownership and simplifies access control policies within ArgoCD projects. The core principle is declarative deployment. We define what the system should look like, not the steps to get there. Prerequisites for installation are a functional Kubernetes cluster and kubectl access. Install ArgoCD into the ArgoCD namespace using the official install manifest. Apply the manifest directly. kubectl apply-n argocd-f https://raw.github.com/argoproj/argocd/stable/manifests/install.yaml. Once deployed, retrieve the initial administrator password. This password is stored in a Kubernetes secret named ArgoCD initial admin secret. Use kubectl get secret argocd initial admin secret -o json path curly braces data password curly braces -base64-d to extract the temporary credential. Access the user interface by setting up port forwarding to the ArgoCD service on port 8080. Immediately change the default password after initial login for security compliance. The application custom resource definition is the central configuration object in ArgoCD. It links the target cluster, the source Git repository, and the synchronization parameters. Define the spec.source block, specifying the repository URL and the target revision, usually head or a specific branch like main. Crucially, use the spec.source.path field to point to the specific subdirectory within a monorepository structure. The spec.destination block requires the target cluster server URL and the namespace where the resources should be deployed. If deploying to the cluster where ArgoCD runs, use the internal Kubernetes service address, kubernetes.default.svc. Ensure the Application CRD is committed to the Git repository itself, enabling GitOps management of ArgoCD configurations. Automated synchronization is essential for true GitOps implementation. Within the Application CRD, set spec.syncPolicy.automated to enable continuous reconciliation. To prevent manual cluster changes from persisting, enable the SelfHeal flag. SelfHeal automatically reverts any configuration drift detected by ArgoCD, restoring the state defined in Git. Furthermore, set the Prune flag to true. Prune ensures that resources removed from the Git manifests are also deleted from the live cluster. Without Prune, resources deleted in Git would remain orphaned in the cluster, leading to resource waste and security vulnerabilities. These three flags, Automated, SelfHeal, and Prune, form the foundation of robust declarative deployment. Committing raw secrets to Git is strictly forbidden. We integrate sealed secrets by Bitnami to manage sensitive data securely. First, install the sealed secrets controller into the cluster. Then use the kubeseal command line to a locally. Create a standard Kubernetes secret manifest containing the sensitive data. Instead of applying the secret, pipe the manifest through kubeseal using the public key provided by the controller. This generates a sealed secret object, which is safe to commit to Git. The sealed secrets controller running in the cluster is the only entity capable of decrypting the object back into a standard Kubernetes secret, ensuring that only the target cluster can access the plaintext data.
ArgoCD provides native support for popular configuration management tools. For Helm charts, specify the chart name and the repository URL within the Application CRD source block. Use the spec.source.helm.values field to define parameter overrides directly in the application manifest. This avoids managing separate values files if the overrides are minimal. For Kustomize, simply point the spec.source.path to the directory containing the customization.yaml file. ArgoCD automatically executes the Kustomize build process before applying the resulting manifests to the cluster. This integration allows complex, parameterized deployments to remain fully declarative and managed through Git. ArgoCD can centrally manage deployments across multiple Kubernetes clusters. To register an external cluster, use the ArgoCD cluster add command line tool. This command requires the kubeconfig file of the target cluster. ArgoCD extracts the necessary credentials and stores them securely as a Kubernetes secret within its own namespace. Once registered, the external cluster URL becomes available for use in the spec.destination.server field of new application CRDs. Use ArgoCD projects to enforce strict RBAC policies, ensuring that specific teams or applications can only deploy to their designated target clusters, maintaining strong isolation. In a GitOps workflow, rollbacks are achieved by reverting the Git commit that introduced the faulty configuration. If a deployment fails or causes instability, revert the repository state to the last known good commit using git revert or git reset. ArgoCD detects this change in the Git history during its next synchronization cycle. It immediately applies the older, stable set of manifests to the cluster, effectively rolling back the deployment. This method ensures that every deployment state, including rollbacks, is fully auditable and traceable back to a specific Git hash, eliminating manual intervention during critical recovery periods. Sometimes, resources require actions before or after deployment. AutoCD supports synchronization hooks defined using Kubernetes annotations. Use argocd.argoproj.io/hook/presync to execute a job before the main application manifests are applied. Use postsync for cleanup or verification tasks after deployment completion. Define the hook deletion policy using argocd.argoproj.io/hook/delete policy. Setting this to hook succeeded ensures the temporary job resource is automatically removed only if the job completes successfully, preventing resource accumulation and maintaining cluster hygiene. The most frequent synchronization failure involves insufficient permissions. If an application shows a sync failed status, check the ArgoCD logs for RBAC errors. Verify that the service account used by the application has the necessary cluster role bindings or role bindings in the target namespace to create or modify the required resources. Another common issue is resource dependency failure. If a custom resource definition is missing, the application deployment will fail. Ensure the CRD is applied and ready before the dependent application manifest is synchronized. Use the ArgoCD app diff command to compare the live cluster state against the desired Git state immediately, pinpointing the exact discrepancy causing the failure.